So today we continue with numerical problems based on what? Van der Waals constant or Van der Waals equation. So based on Van der Waals equation, the important numericals we are going to study today. Okay. So the numerical problems is means the concept of numerical problems is very important here in this chapter, means in this subtopic. Okay. So here, first example, calculate the pressure exerted by 16 grams. Here mass is given here. Given mass is what? 16 grams. Calculate the pressure exerted by 16 grams of methane. Methane formula is what? CH4. What is gram molecular weight? Gram molecular weight of methane is what? 16 gram per mole. 16 gram per mole is what now? The gram molecular weight of methane. And what is the given weight of methane? Given weight is what? Given weight is 16 grams. Gram molecular weight is also 16 grams. Therefore, how many moles now? Number of moles is equal to number of moles given mass by gram molecular mass. Given mass is 16 by gram molecular weight is 16. So 1 mole. So 1 mole we have to take. Is that clear now? So 1 mole is taken here. So 1 mole is taken. Next thing is that, next important thing is that, okay, so now 1 mole is given here. 1 mole of methane is given. And what is the volume given in a 250 ml? In a 250 ml. So volume is given here. If you want to take in liters, what now here? 250 ml by 1000 ml is equal by 1000 is equal to what now here? Volume in liters. So volume in liters we have taken generally. So how to convert milliliters into liters? Given milliliters by 1000 will be liters. And what is the Kelvin temperature given here? 300 Kelvin. Already temperature is mentioned in Kelvin only. Need not to convert. If centigrade temperature is given, we have to convert into Kelvin temperature using Van der Waals equation. So calculate the pressure exerted using what? Van der Waals equation. So what are the given values? Number of moles given 1 mole, volume given, temperature given. Pressure we have to calculate. What pressure will be predicted by ideal gas equation? Okay, what pressure will be exerted by ideal gas equation? What pressure by using Van der Waals equation? Both we have to calculate. Okay, and here it is what now? A value is what now? Magnitude of attractive forces. Magnitude of attractive forces is given by A value. A is what? Van der Waals parameter. And next B is what now here? Size of gas molecule. Otherwise, volume of gas molecule is given by this one, B. And R is what? Universal gas constant. Universal gas constant. Okay, so we have to calculate what now here? Pressure exerted. Out here. Given what here? 16 grams of methane means given mass by gram molecular mass. Gram molecular mass in grams per mole. Now here how many moles we got? 1 mole we got. Applying Van der Waals equation, here pressure of real gas plus AN square by V square. Pressure of real gas by plus AN square by V square. V real gas minus NB. NB is what? Volume correction. AN square by V square is what? Pressure correction. Is equal to nRT. N into RT. So the pressure we need to calculate now here. What we need here? This pressure we need here. Pressure is equal to what now here? nRT divided by what? V minus NB minus AN square by V square. Here plus AN square by V square will go this side now. It becomes minus AN square by V square. And nRT by V minus NB. nRT by V minus NB. So by using this formula, we have to get what now here? Pressure of real gas. Pressure of real gas based on what? Van der Waals equation. Substituting number of moles 1 and R value 0.0821, temperature 300 Kelvin, volume in liters you see, volume in liters. So 250 ml by 1000 we have taken. Okay, volume. Next, A is what? Magnitude of attractive force given to you, and B also is given, size of the gas molecule given. Okay, so it is about what now here? The given values. From this, P is equal to what? P is equal to nRT minus V minus NB minus AN square by A value n square. N square means 1 square now here. 1 square means 1. By what now here? N square by V square. So V square. So like this we get what 82.8 atm. Pressure how much we got here? 82.8 82.8 atm. According to what now here? Real gas equation. The pressure of gas from real gas equation, that is Van der Waals equation, is how much? 82.8. Got it, one? So this point keep in mind. Next, by using ideal gas equation, the ideal gas equation predicts that what is the formula? PV is equal to nRT. No? PV is equal to nRT or ideal gas equation. So from this, P is equal to nRT by V. N is number of moles, R is universal gas constant, temperature by volume. Then we get 98.52. Generally, for the given conditions, the pressure exerted by ideal gas, this is pressure ideal. Pressure exerted by ideal gas will be greater than what? Pressure exerted by real gas. It is what now here? Pressure exerted by real gas. It is what? Pressure exerted by ideal gas. Generally, pressure exerted by ideal gas will be greater than what? Pressure exerted by real gas. Why? In ideal gas, between the gas molecules, no attractive forces. There is no attractive force between gas molecules. So more pressure will be exerted. But in real gas, between gas molecules, there will be attractive forces. When there are attractive forces between the gas molecules move slowly. They will move slowly and exert less pressure. But here, more pressure will be exerted by ideal gas. So this concept we have to understand. Next. Example 48 means example 2 in our discussion. Okay. So here, calculate the temperature of the gas if it follows Van der Waals equation. Calculate the temperature. Now temperature we need to calculate here. So calculate the temperature of the gas if it obeys what? If it follows what? Van der Waals equation from the following data. So a flask of 2.5 liters. So volume is given to you. Volume is given 2.5 liters. It contains 10 moles of a gas. So what is the number of moles given here? 10 moles. Number of moles given 10, volume given 2.5 liters. And temperature we need to calculate from Van der Waals equation. Under 50 atm pressure. So pressure is given what now here? 50. Pressure is given 50 atm. Given A value and B value. B value given, A value given for that particular gas. So we need to calculate what now? Temperature from equation. Yes. So here what is given here? Given data what now here? Pressure is given, volume is given, number of moles given, A value given, and B value given. Now R is what? 0.0821. We have to recall this one. We have to remember it. Sometimes it will be given, sometimes not. So it should be remembered. Next, applying Van der Waals equation of applying what? Real gas equation. Applying real gas equation. So real gas equation or Van der Waals equation, both same now. So real gas equation is also called Van der Waals equation. So by using this, here pressure of real gas plus AN square by V square, that is pressure correction, into V of real gas minus NB. NB is what? Volume correction, is equal to nRT. Now we need to calculate what in this T value we need here. T is what? Not temperature we need. Remaining all the values given to you here. So T is equal to what? P plus AN square by V square into V minus NB, left hand side, by NR. From nRT, T we are calculating. T is equal to this formula. Next year, applying all these values, okay, we get 366.4 Kelvin. So this calculation part, you please try. Okay, after means when I send this PPT, every problem please do on your own. Okay, now in this PPT, some problems we'll discuss and some problems you have to complete. You have to do. Whatever we have discussed from that problems also, this calculation part is important. Whatever is given here, this calculation part, this total calculation part, you have to do on your own. And final answer you have to get. Whether you are getting nearby this answer or not, we have to check. Okay, the calculation part is very important, remember. If you remember only the formula, no use. And some of the students have sent the doubts, problems, numerical problems from material they have sent. But after discussing all these problems, you can do once again on your own from material, whatever you got doubt, whatever you have sent to me, okay, to clarify doubts. That all doubts, once again, check it on your own. You think from the concept what I'm giving now. We are discussing some of the example problems now. From this concept, once again, try to do those doubtful problems, whatever you have got. Next. Now, another example problem is that at high temperature, and low pressure, at high temperature and low pressure, the van der Waals equation is reduced to what? Reduced to what? We have discussed some of the areas now, case 1, case 2, case 3, at different temperatures and at different pressures. So here, low pressure is given here condition, low pressure and high temperature. Okay. So here, how it will be reduced, we have to understand here. So at high temperature and low pressure, generally what now? Any gas will behave like what? Ideal gas. Any gas will behave like ideal gas at high temperatures and low pressures. So low pressure means what now here? Volume is inversely proportional to pressure now. So when pressure is low, volume will be large. So volume is large. Volume is large. Okay. Next, here high temperature. At high temperature. At high temperature means what? How volume and temperature related directly. When temperature is high, volume is large. When temperature is high, what? Volume is large. So in both cases, what? Volume is large. When volume is large, what happens here between the gas molecules? Distance will be very large. When distance is more between the gas molecules, attractive force will not be there. No attractive force. No force of attraction. No force of attraction between the gas molecules, right now. And also remember that, now one answer, just a moment. Here I'm stopping this one here. That means locking meeting. When we lock meeting, what happens? It will not be allowed. Others will not be allowed now here. No participants can be allowing. Okay. And now see a reason. So now in this case, now here what we have to understand is that, so what is to calculate in this here now? What is to observe? How real gas equation will be reduced when we take what? High temperature and low pressure. So under these conditions, when volume is large in both cases, what happens now? The distance between gas molecules will be very large. That's why the attractive force of attraction will be less. When force of attraction is less, A value will be less. A is negligible. A is less. A is very less. When A is less, the pressure correction will be less. Pressure correction P dash is equal to what? AN square by V square. Na? When A magnitude of attractive force is less, pressure correction can be neglected. Pressure correction can be neglected. And in comparison to large volume, volume of gas molecule, that is 4/3 pi r cube. The volume of gas molecule is neglected. It is negligible. So volume of gas molecule is negligible means B is negligible. Van der Waals constant B is negligible. So B is what here? The volume correction. B is negligible. So B is negligible, pressure volume correction is negligible, and P dash pressure correction is negligible because A is less. Why A is less here? Attractive force is less because of large volume. As that the volume correction and pressure correction both will be neglected, and that's why the real gas equation will be reduced to what? Ideal gas equation. It will be reduced to ideal gas equation. So hint is given what? At high temperature and low pressure, volume is large in comparison to what? Volume of gas molecule. In comparison to volume of gas molecule, it will be reduced. It means very less. B is very lesser than what? Volume of gas. So B is very less than what? Volume of gas. Total volume of gas and B value if we compare, B is very less than what? Volume of total gas. That's why B is neglected. That's why B value neglected. And an and what is A by V square? An square means 1 mole. If you take An square becomes A, N square becomes 1. If N square is equal to 1, okay, 1 square, and An square means A only. A by V square is negligible. Why A value became very less now here? Why A value became very less? Because of less attractions here. That's why this pressure correction also will be neglected. And when volume becomes very large, when volume denominator becomes very large, this total ratio becomes very less. Na? When this denominator value V square becomes very large, this total ratio A by V square ratio becomes very less, so that it can be neglected in comparison to pressure. of gas. Hence, the equation is reduced to what? PV is equal to RT. This is what now here ideal gas equation. So the real gas equation became what? Ideal gas equation. Real gas equation became what? Ideal gas equation. Next, the constant A, another problem. The constant A is what? Magnitude of attractive force now. Whenever you see small a here, what we have to recall? Magnitude of attractive force. In van der Waals equation is maximum in. So the constant A in van der Waals equation is maximum in case of what? So in case of what now here? What here? Helium, hydrogen, oxygen, and ammonia. So what is asking? A is maximum. A is maximum means what? A is maximum means what? Maximum magnitude. Maximum magnitude of attractive force. Attractive forces. So here the ammonia has more magnitude of attractive forces because it is easily liquefied. So which gas can be easily liquefied here in the given list? Ammonia can be easily liquefied. Why it is easily liquefied? Because it shows what now here? It shows more negative deviation. More negative deviation from ideal behavior. So ammonia shows more negative deviation from ideal gas behavior. Therefore, ammonia can be easily liquefied. Ammonia is easily liquefied, meaning what? More attractive force between the gas molecules. That is, A value is greater. So A value is greater in which case here ammonia, because ammonia can be easily converted into liquid. That point mainly you have to remember. So easily liquefied. Why? Here the graph is there now here, one graph. In this graph here, it is ideal gas. So what is Z value? Z means what? Compressibility factor, PV by RT. Z equals to PV by RT versus what now pressure if you take. So this what here? It is ideal gas here, parallel to x-axis. The line parallel to x-axis is ideal gas. Z value 1. Okay, Z value 1 here. If it is showing like this now here, it is what? Negative deviation. And if the line is like this, it is positive deviation always. This positive deviation, it is negative deviation. So this negative deviation, more the negative deviation, more will be liquefaction. More easily it can be liquefied. More easily it is liquefied, meaning what? More magnitude of attractive force. More magnitude of attractive force means greater value of A. A value is greater. Constant A is greater. So hint is given what now? Intermolecular force of ammonia is maximum. That's why it can be easily converted into liquid. Hence, its van der Waals constant A will also be maximum. So that point. Theoretically, we have to remember all these things. Next, the van der Waals equation for 0.5 mole gas is what? Okay, so here N is given what now? 1 by 2. N is given what? 0.5, 1 by 2. So wherever N is there, N square becomes what now? 1 by 2 whole square. That is equal 1 by 4. Wherever N square is there, what we write now here? 1 by 4 we write. So what is the formula generally? First write formula here. P plus A N square. A N square by V square into V minus NB is equal to nRT. It is ideal gas, real gas equation. In this real gas equation, wherever N is there, what we have to write? 1 by 2. So here in place of N, what we write here? 1 by 2 means B by 2 here. Here in place of N square, what we write? 1 by 2 whole square, 1 by 4. So like this, we have to take it. Okay. So now what is the equation here? B. You can now see int is given P plus N square by V square into V minus NB is equal to nRT. So N is what? 1 by 2, half mole. So P plus A into N square. Now N square means 1 by 4. So 1 by 4. So 1 by 4 we have taken in place of N square. In place of N square. Next, A by N, 4 V square into V minus NB. So here 1 by 2. In place of NB, what we have taken? N is V by 1 by 2. So B by 2. Okay. So that is equal to 1 by 2 RT we get. RT by 2. RT by 2. Then here means what here? Why it is so? Again N. In place of N, what we wrote here? NRT means 1 by 2 RT. So it is what now here? P plus A by 4V square into, okay, 2V minus B is equal to RT. So this formula we can take here. Is that clear? So option B you take here. Option it will be this one. So once again check all these things here. Not only this one, sometimes what will be asked if N equals to 0.25 moles. 0.25 moles means what? 1 by 4. If N is equal 1 by 4, then N square becomes what now? 1 by 4 whole square. That means 1 by 16 becomes. So N square will be 1 by 16 sometimes. Okay. So whatever is given, you see here. Okay. Like this. Next. Van der Waals constant of two gases given. Okay. For X and Y. For X and Y, what are given here? Van der Waals constants given to you. For X gas and Y gas given. See here. For a gas X, A value given 5.6 and B value given 0.065. And for gas Y, A value given 5.1. So which is having more A value of X is more than what? A value of Y. A value of X is more than what? A value of Y. Is that clear, ma'am? So next, B value, check it here. 0.065. 0.065. 0.065 given for X, and for Y, what is this here? 0.012. So 0.06 is greater than 0.01. 0.06 is greater than what? 0.01. That's why X is having more B than Y, and X is having more A than what here? Y. Now what they ask here? These are all given data. What is correct about the two gases? What is about two gases correct? Now here TC given here. TC means what here? Critical volume. Okay. VC is what now here? Critical volume. I told you about these critical constants we'll discuss later. Okay. So critical volume is equal to VC is equal to 3 into B. 3B. So what is critical constant here? 3B. So critical constant is what? 3 into B. We have to take here. Okay. So in this case now here, 3B is what now here? Critical constant VC. So remember that critical volume is equal to 3 into B. 3 into B. About these critical conditions we'll discuss later. But anyhow, as we are discussing important problems, once again try to understand that critical volume VC is equal to 3 into B. 3 into B. Is that clear, ma? Now here B is what now? Size of the gas molecule, otherwise volume of the gas molecule we know. Now B value is given to you here. Now here 3 into B we had to get. So 3 into B for X gas and 3 into B for Y gas. Okay. So where it is more of 0.1, here 0.03, 0.03, 0.1, which is greater, it is greater here. So X will be having greater VC. So X gas will be having greater VC than Y value. For Y gas VC and X gas VC, which is greater? The critical volume of X is greater than what? Critical volume of Y. So about critical constants we are going to discuss. Okay. Next one, select the correct statements. Select the correct statements about van der Waals constant. About van der Waals constants, the correct statement we have to get it. Okay. So now what is given here? Select the correct statements about van der Waals constant B. About B they asked here. Is that clear, ma? So it is excluded volume. It is excluded volume, correct. Excluded volume is also called what, ma? Co-volume. Co-volume or excluded volume we say here. So B is indicating what now here? B is also called excluded volume or co-volume, remember. So co-volume or excluded volume. And it is correct statement. They asked about correct statement, now it is correct. And its units are mole per liter, they said. Mole per liter. Now we know that volume correction, now. Volume correction. Volume correction is what now here? Volume correction is given by NB, na? N into B. So now here B is equal to what? Volume correction by V dash means volume correction. Volume correction by N. So volume correction meaning what now? Liters. By N means mole. Actually, what is the unit here? Liter mole inverse. Liter mole inverse is the unit of B. For B, units will be liter per mole. But here what is given? Mole per liter given. mole per liter. So it is not correct. But they asked to find out what correct statements. It is excluded volume is correct or co-volume. Next, it depends on intermolecular forces. It means what now here? B. It means what now? B. It means what? B. So B means what now here? B is what now here? It depends on intermolecular forces. Is it right or wrong? It is wrong. So now B is wrong here. B is what? Wrong. Because B, it means what? A. B. B is what now here? It is size of gas molecule. It indicates what represents what size of gas molecule or volume of gas molecule, but not the attractive force. Is that clear? So next, its value depends on molecular size. Its value depends on what? Molecular size, correct. Its value depends on what? Molecular size, correct. Okay. So what now here? Now answer becomes what now here? 1 and 4. 1 and 4. Where 1 and 4 not given anywhere. So these given options are wrong here. So now generally volume correction is what now here? NB na? So here B is equal to V dash by Nm. V is what? Liter. Liter per mole we have taken. Liter mole inverse we have taken. See in all these problems here, liter per mole given, you see, B value. B value given what in this case? B value liter per mole. Liter per mole we have taken. But here given what now here? Mole per liter. Here printing mistake must be given otherwise. So you take it as what now here? You take this one like what now? Liter mole inverse you take. If it is the units of B, if you take liter per mole, then you take it as correct. Okay, so a printing mistake is given. Instead of mole per liter, what should be there? Liter per mole should be there. Then you take this one correct. So 1, this one if it is given 2 correct, and it is 3 correct, 4 correct. But 3 is wrong here. B depends on intermolecular force, wrong. What will depend on intermolecular force actually? A. A is what now? Magnitude of attractive force. That A will depend on intermolecular force, but not B. So B is wrong statement here. So you take 1, 2, 4 right. But you take this one liter per mole, remember. Okay, ma. Next. Now another one is that gases like X gas, Y gas, and Z gas, P and Q. X, Y, Z, P, and Q. These are different gases given here. They have the van der Waals constants A and B. A value and B value given here in CGS system. In CGS system, they have given what now? A value and B value. Okay, as shown below. Now here, A is given, B is given for different gases. How many gases given? 1, 2, 3, 4, 5 gases given here. Now among all these here, A value is greater for what? Here. So more A value here. More A value, more A value here. So maximum A value is here for Q, right now. And here maximum B value where? Here 0.02, 0.1. Okay, it is greater than this one. And 0.15, 0.10 here. 0.10, 0.15. 0.15 is more than 0.10. And 0.02, 0.2. So 0.2 here. It is maximum here. So 0.2 is here. So maximum B value. So maximum B value, maximum Q value here. Okay. So this point to keep in mind. And here it is what minimum 0.02 is what? 0.025 here. Here 0.020. 0.002, 0.025. Okay, it is least value. So now what they ask here, the gas with the highest critical temperature. The gas with highest critical temperature, TC. TC is equal to, I told you now, CBI, I told you, CBI. I read here. So what here? Critical temperature, boil temperature, inversion temperature. Okay. So critical temperature, here inversion temperature value is greater than boils temperature value greater than critical temperature. It is critical temperature, TC. Okay, ma. So 8 A by 27 RB. 8 by 27 into A by RB. Here boils temperature is A by RB. Means 1 into A by RB. Here it is what? Inversion temperature 2A by RB. 2A by RB. So 2 into 2 into A by RB. Here 1 into A by RB. Here less than 1. 8 by 27 means less than 1 into A by RB. So whose magnitude is greater here? Inversion temperature magnitude is greater, high. High temperature is what now here? Inversion temperature. Inversion temperature is high. Okay. So this point keep in mind here. Is that clear now? So now here in this case, what they ask now, critical temperature they ask you, highest critical temperature. Critical temperature formula what? 8A by 27 RB. In this here, R is constant here. And here A by B you take ratio. A by B ratio we have take. Now here, critical temperature. Critical temperature is directly proportional to A by B. The ratio of A by B, if it is greater, if ratio is greater, the TC will be greater. TC will be greater if A by B ratio is greater. So in every case, in every gas, we have to take which ratio? A value by B value we have to take ratio. A by B ratio you take for every gas. Is that clear, ma? So whichever is having more A by B value, that will be having more critical temperature. Because R is constant for all gases here. That's why for all gases, critical temperature now formula will be same, but A value and B value will be changing for different gases now. That's why A by B ratio you take always. So A by B ratio is more indicating what? More critical temperature. Is that clear, ma? Hint is given here. See, critical temperature is given by TC is equal 8 by 8A by 27 RB. This one. A by B you take. A by B ratio you take. A by B ratio you take. Next. So greater is the value of A by B ratio. More is the critical temperature of gas. So for X gas, for the gas X, TC will be maximum. Why? Here TC is what now for X gas, what A by B, what A value by B value will be 240 here. For all other gases given here, A by B value is lesser. That's why answer is what now for X gas, it is a maximum. Next, at high temperature, at high pressure, van der Waals equation becomes what? At high pressure, van der Waals equation becomes what? At high pressure, what happens now? Volume becomes very less. Volume becomes volume of gas becomes less. When volume of gas becomes less, B is not neglected here. B is not neglected. When B will be neglected, if volume of gas is very large, if volume of gas is very larger than B, in that case only B can be neglected. But here gas volume is becoming lesser now because of high pressure. When you apply high pressure on the gas, what happens to the volume of gas? Volume of gas becomes less. When volume of gas becomes less, what happens, mom? When volume of gas becomes less, B value cannot be neglected now. B means volume of each gas molecule. Size of each gas molecule is what B. The B cannot be neglected. Okay. So that point keep in mind. So B becomes less and B is not neglected therefore. So B will be there. So formula is what now here? P plus AN square by V square into V minus NB. Okay, V minus NB is equal to nRT. If you take 1 mole, it will be 1, it will be 1, it will be 1. Then it will be 1 mole here. For 1 mole gas now here, B cannot be neglected. B should be there in the formula. B should be present. But here, pressure correction can be neglected. High pressure means what now? The pressure of gas and pressure correction. If you take now here, this pressure correction becomes what? Very lesser here. The pressure correction becomes very less in comparison to high pressure. In comparison to high pressure of the gas, the pressure correction becomes very less. So pressure correction can be neglected. So this pressure correction can be neglected here. It is neglected in this condition. The given high pressure condition, the pressure correction can be neglected. So in the place of P we write. P into V minus B for 1 mole is equal to 1 into RT becomes nRT becomes 1 RT. So now here P into V, PV minus P into B, PB is equal to RT. Then PV is equal to what now? PV is equal to RT plus PB. So this formula we have taken. It becomes PV is equal to RT plus PB. Next now, this is the same hint given, you go to later. Next, so these all problems you go through one by one. We will discuss the next class. I will send you the PPT today only. Solution is there, and please go through it without fail. And the final answer you must get on your own. Final answer you must get. Now see, this one is what you have, critical volume. What is that? Critical volume, which is given by formula what? 3 into B. B is what? Van der Waals constant. And Tc is what? Critical temperature. What is here? Critical temperature. Critical temperature Tc. 8A by 27 RB. 8A by 27 RB is what now? Critical temperature.